All right. Final 15 questions. Just like the last test, they're not going to be nearly as long as some of the questions on the homework, the assignment on on MyLab. So, and they're going to be like the last one, where it'll be just the questions and you have to explain out what you're doing and whatnot. First thing is, though, there is some definitions. Remember, this is cumulative, so this is back to the very first chapter. These are the only words that I will put on the test. The ones in the black. So those are the words you need to know for this question. I won't put any of the other ones on there. Okay? So I will not have nominal, ordinal, those on there. If it's not on that list of 10, I will not put it on the test. I do not know if I'm going to ask you all 10. So, like I said, I'm going to cut down some of the questions. But those are the 10. Okay, let's go. I could have just done it this way. So statistics is a science of collecting and organizing numbers. So that's the first one. The population is the entire group of individuals to be studied. The response variable is the variable of interest in the outcome of the study. Quantitative variable provides numerical measures of individuals. The quantitative variable can be added, subtracted. That's the key piece there. Is that quantitative can be added and subtracted. I can do some calculations to it. Qualitative is classification of individuals on an attribute or characteristic. They do not necessarily, they do not have to be numbers. They can be anything. Okay. However, a number can be qualitative, like social security number, phone number, things like that. Variable is a characteristic of the individuals in the population. A designed experiment is a researcher that randomly selects individuals for the study, organizes them, and does the controls and all that stuff. An observation study is the researcher is not influencing the outcome. They're just observing. They could be doing that just by collecting data or things behind the scenes or looking at records. They do not necessarily have to interact. A lurking variable is an explanatory variable that was not considered in the study. So things that could cause problems, but you were not actually looking for. And a confounding occurs when the effects of two or more explanatory variables were not separated. Therefore, we can't tell the difference between the two. All right. All right, let's look at a study. And I'll answer some questions on it. Actually, I should have this one. What type of study is this? So we got cohort, randomized block, matched pairs, or case control. So keywords in the problem, it says each tooth was randomly assigned. So they took 64 teeth and just randomly assigned them. So it's a completely random design. Yeah. What was the treatment? What was it? So remember, treatment is what they're doing. So what are they doing in this one? Okay. So that's is that what they're actually trying to, like, is that the differences between the two, or is that? Like what they're trying to do is actually get rid of the stain, right?
Yeah.
So then the treatment, and actually even says, sign one of the 4 treatments is the gum. How many levels of treatment are there? 4. Now, the stain comes into what's the response variable. What are they testing? The percentage of the stain removed. Oh, actually, it says the color change. Sorry, they were looking at the color change. So whether the color of the tooth improved or not. So that would be the response variable. It is? Oh, you know why? And this is where I'm going to fix things because it says or not. So the difference between these two. So the this is a either or situation where the percentage of stain is a gradient. So that would be why they're that's I'd have accepted either one of them. I could do that. And we're not going to put that one there. All right. All right. Those are the ones I'm going to ask you for that one. All right. So for this one, I'm not going to give you a picture of the histograms. You're going to make them, but I'm going to have the boxes there. So a construct a relative frequency distribution. You'll have the age, the births, and then there'll be a column that says relative frequency. So you'll have to do the calculations there for them. How do you do a relative frequency? Relative frequency is no different than percentages. How would I find the percent of births between 10 and 14? Mm-hmm. I'm going to add them all up and then divide 2,500 by that number. Okay, so relative frequency is just going to be so 2,500 divided by the total, and just do each of the calculations. Yeah.
Is this review on?
Not yet.
Not yet.
It will be. It'll be after I finish writing it. I wasn't sure what I was going to cut in and out, so that's why it's not there. And I'd add it, except I don't have time to add it really quickly. Frequency histogram. What is a histogram? Go ahead.
Well, I know how to describe it. It's just a bunch of bars with whatever the year is, and then on the left it's your second factor. In this case, births, and then it measures it by the year.
Yeah, they're going to be classes, and the classes are going to be touching each other. So the age is the classes, and the births is the actual bars. So I will have a graph there, and I will have boxes for them, and I will have the numbers on the side. So you just got to fill in the things and draw your little boxes. I probably will just, since these two are basically the exact same thing, I'm probably not going to have you do that part. So this one, because I am going to have you do that. So let's say this is the histogram for it. Symmetric, skewed left or skewed right? Symmetric. All right, so you're just going to have to tell me what it is. Questions on this one? Okay. So this one, you're going to calculate the mean, median, range, sample standard deviation, and interquartile range. So for this one, we do have calculators that you can use for it. That gives you. Oh, there it is. But this one's not going to give you your. So this calculator here, A8, will give you your. So A8 will give you your median, your range, well, you can easily figure out your range from it, your IQR on them. So that'll give you those. And the standard deviation calculator. This will give you your mean and your standard deviation. So this is A11. So all you're going to do, type those numbers in, and it gives you it out. So for example, here, this one you type in the data set, and it gives you your standard deviation. The piece that you have to make sure of is that you're using the correct one for standard deviation. So this one says data represents the dollars for 9 2-year-old cars. So is that the entire population, or is that a sample? That is a sample. So we're going to want to use the sample standard deviation, not the population standard deviation. And then the mean doesn't matter for those two. The mean's right there. And then this one, you put your values in. It's going to give you your IQR. This also gives you your lower level. So your Q1 and your Q3 is there. So this question doesn't need that, but this question does. So what I'm probably going to do is I might actually make the final exam only 10 questions. But because what I'm probably going to do is, since these two questions are basically the same, they're asking very similar pieces of information, I'm going to take and put, this will just have more questions or more numbers in it. So this way you can find out your Q1, your Q3, and do the box plot with it. Since these two are basically asking you the exact same thing. Because there's your 5-member summary that you're looking at. So, and I will make sure there will be a possibility of some outliers in there as well. So, you think you're going to do okay with this? Okay. I think this was question from the review 4 and 5. Yeah. So when you're studying, you know those are only going to be one question and 2 questions on the front. Any of these terms you don't know, or we're good? Remember, the quartiles are not telling you standard deviation. Your quartiles are mean. So in this case, the answer is C. 25% or less in the first quartile, 50% or less in the second quartile, 75% or less in the third quartile. There's 50% in between the quartile 1 and quartile 3. Okay, it has to do with the median of the values and the count of the values, not the actual standard deviation, which is mean. So. Remember how to find outliers?
Going back to quartiles, is that is A8?
Oh, quartiles was A8, yeah. Quartiles was A8. So outliers are Q1 minus 1.5 times the IQR, or Q3 plus 1.5 times IQR. So if it's outside of those two, those are your outliers. Any questions on that one? All right. I know, I'm going quick on purpose because it's going to take a while for some of them. A roulette wheel consists of 38 slots. Determine the probability that a metal ball falls into a green slot. So what's the probability that it's going to fall into a green slot? How many greens are there? 38.
Oh, right.
There's 38 numbers. It's 36 numbers plus the 2 green ones. And you can leave them as fractions. You don't have to do 2 out of 38 is totally fine. What's the probability that it falls into a green or red slot? How many red numbers are there? Yes. Oh no, sorry, 36. So it's 18. So there's 18 red and how many green? So we would do the 2 over 38 plus the 10 over, or 18 out of 38, which is 20 out of 38. What's the probability it falls into double 0 or a red slot? It's 19 over 38. The only one we're taking out is the 0. So it's that one minus that 1, 0. So it's 1 out of 38 plus the 18 out of 38, which is 19 out of 38. What's the probability that it falls into number 31 and a black slot? Okay, there's a key piece. This is where the wording comes into play. 31 and, where the other ones were or. So read the problem. Is 31 black? No. So can it fall into 31 and a black slot at the same time? No. So that means this does not happen. So what kind of event is this? Impossible. That can never happen. Okay. What's the probability that's falling into red or black? Huh? 36 over 38. Okay, that actually has a probability. It is not 100% because there's those green ones. Okay, but read that because if it's at 30 in a black slot, that can happen. Okay, because 30 is black, so that would have been 1 out of 38. All right, so don't make sure you're reading exactly how it's written because that actually will make a difference in the questions. All right, so this is that conditional probability charts. So, what's the probability that a randomly selected born baby in this year was post-term? So, what would we do? Well, we have that actually. That's right here. Yeah, so you're just going to take that divided by that. Okay, so we would take that and divide those two. What's the probability that select a baby born in the year weighed between 3,000 and 3,999 grams? Nope. Total. Yeah. It's that divided by that. Hold on, because I want this exactly as it's worded. I think I have it here. So, what's the probability that a random selected baby born this year weighed 3,000 to 3,900 grams and was postpartum or post-term? Sorry. So this one has that word "and" in it. So in that case, we're just looking at that number right there. That number is the 3,000 to 3,900 and post-term. We would then divide that by the total. Okay. Well, so the next one, the way it's worded, what's the probability that a random selected baby born, no, not that one. What's the probability that a random selected baby born this year weighed 3,000 to 3,900 given that the baby was post-term? So remember that given means we're looking at the total for that column. So unlike this, so we're still using that same, that number right there, because that's that. But we're saying given that they're post-term, so we're dividing it by the 221,000 this time. Okay. So since we're given that as post-term, we're using that total. And if I said, what's the probability that a baby born was 3,999 pounds, given that they were, or given, what's the probability that a baby is post-term, given that they are 3,999 pounds? It's still that number, But this time, that statement, because I'm going this direction, I would divide by that total. So the given is going to be what you're dividing by. The given is your bottom number. The combination of those is the top number. That makes sense? Think about it. This is your last time to ask questions. So if it doesn't, make sure to tell me. Okay. The probability that a random selected patient who visits the emergency room will die in 1 year of their visit is 0.07. So this is a binomial probability. How do we know it's a binomial probability? There's two outcomes. You're going to die or you're not going to die. Those are your two outcomes. Okay? So when we're looking at it, the calculator we can use for this one is binomial probability calculator. So in this case, my probability depends on what they're asking. So the first question says, what's the probability that exactly 1 out of 10 selected visitors will die in the ER within 1 year? So I've done 10 trials. My probability is 0.07, and I want 1 success. So exactly 1. Exactly 1. So it's the 3643. So this calculator is 822. What's the probability that fewer than 2 out of 25 random selected visitors will die within the first year? So my trials have now gone up to 25, and I have 2, and it says fewer than, and that was nice, and I even put those words in there for you. So fewer than is 0.4696. What's the probability that at least 2 of 25, nice thing is we don't have to change anything, and that's 0.5304. Which sounds crazy. That there's a 53% chance that at least 2 of those 25 people will die after a year being in the ER, or within a year of being in the ER. Make sure you're reading. This one switches it to will not die. So what I would do is 8 out of 10. I would change that to 0.93. Because now I'm looking at alive. And it says at least 8 out of 10 will not die in the first year. So at least would be 97.9717. I have, no sure. At a particular emergency room, researcher obtains a random sample of 700 visitors and finds that after 1 year, 43 of them have died. Should this particular emergency room be investigated to see if something unusual is occurring? I'm dying to see how they worded this. Should we investigate them? So let's see. So if we did 700, 0.07, and 43 died. So we would expect at most 43 would be a 20% chance that would happen. So, but no, we would expect that to happen at least 26% of the time for at most 43 people to die.
26 or
21, sorry, 21%. So that's not that unusual for that to occur. We would expect that to happen. So if I said 100 people died, that would probably be unusual. Like that shouldn't happen. But 43 is not that unusual. That's within the realm of. That is within the realm of possibilities. All right, next one. The great tire problem. This question is. So, tire manufacturer company was a lifetime, or a tire with a lifetime is approximately normally distributed, with a mean of 70,000 miles and a standard deviation of 4,400 miles. What is the proportion of tires that will last at least 75,000 miles? So, for this one, we can use, since it's normally distributed, we can use the normal probability calculator. So A24. I didn't close my sweater. So I've got 70,000 miles and 4,400 is my and this question was at least 75,000 miles. Would that be less than, greater than, or equal to? And greater than. So greater than 75,000. So 0.12, 1,279. Suppose a company warranties the tires for 60,000 miles. What proportion of tires will last 60,000 miles or less? So we just change this to 60,000 miles. And we want less than that. So they'd only expect about 1% of the tires to come back. And even then, they're going to prorate it based on your mileage. So you're still going to have to buy a tire. And tires are expensive. You just had to go buy them. They were like $1,200 for us out. I'm like, what the heck? Huh? Yeah, they're crazy. Probability that they last between 6,500 and 80,000 miles. So you can do between. Yeah. So that's between. Suppose a company wants to warranty no more than 2% of its tires. So this is where you use the X value. And I want 2%. So I don't think it says round. So 60,963 miles. Nobody's going to advertise that, which is probably why they advertise 60,000 miles. Okay. Questions? I know, it's just a lot to remember. All right. According to a poll, 46% of the people in the country 18 years or older stated that they have read at least 6 fiction or nonfiction books within the past year. You conduct a random sample of 250 people from that country 18 years or older. And now I need the other parts of the question. So first thing we have to do is we want to figure out if they're normal, if it's normally distributed. So since this is a probability, we're going to use for proportion. I think this one is, yeah, this is our probability. For this one, we can just use the sample proportion calculator, which is A28. So my proportion was 46%. And I did a sample of 250 people. So at that point, we can determine that it is normally approximated. 62.1 is greater than 10. So that's there. What's the probability that exactly 125 read at least 6 books? So if I take 125 divided by 250, that's what? Is exactly 0.5. So my sample is 0.5. Now, that's going to give me the whole thing, right? So for this one, since you want exactly point, you go a half down and a half above. So I would do 49, 495, and 50.5. Since they're doing whole percentages, you do above and below it. And that gives you that exact. Let's see what they gave the answer for this one. I think they probably did one, actually. They got two. Actually, let's do 9.5. Half below, half above. Out of every 100 samples of 250 adults, approximately 72 results. Or out of every 100 samples, what's it? Oh, never mind. Two different parts of the question. That's why. I'm like, what? What's the probability that they will read that fewer than 120 read at least 6 books? So I got to do 120 divided by 250. So 48. And we want fewer than that. And then, won't do that one. We've done that one. So that's all you're doing for this one. Depending on what the questions ask, you're going to go each direction. So if it's asking exact, you can do between. If they're asking between, obviously you can do between. Then greater than or less than, depending on which direction it's asking you to do it. So that'll be 828. Let's get that. Which one? All right, let's do this one. Diameter of Douglas fir tree is measured in the height of 1.37 meters. The data represents the diameter in centimeters of a random sample of 12 Douglas fir trees. We want the mean and the standard deviation for this data set. Well, actually, you know what? We can't. We're going to assume this one's normalized. Yeah, we'll assume this one's normalized. So this one, you're going to do confidence interval. So it is A30. So we want a 95% confidence interval for this. So the first thing you're going to have to figure out when you're looking at this is we need to figure out the mean and the standard deviation of the sample data. So for that, we need to use standard deviation calculator, which was A11. And I'm going to see if I can copy and paste these. So my mean was 147.3, and my standard deviation, since this is a sample, is 28.8. And then we can go back and use the mean confidence interval, and we'll put those informations in. So 147.3, 28.1, 28.8. What was my sample size? 12. And if I wanted a 95% confidence interval, that's my confidence interval. Notice it does say it's a small sample. I will mark it that. I'll tell you that it's actually normally distributed in the problem. So that's the confidence interval. If I want a difference confidence interval, you're just going to tell me whichever percentage that I want there. Yes.
It's both those numbers, correct?
Yes.
Okay.
Yeah. It's because remember, confidence intervals go in both directions. It's in essence a two-tailed test. So you're going one direction and the other direction. So yes, you need both. Is the difference between the middle and one end. Yeah. Yep. I'm not going to ask you sample size. I just asked you that in the last test. Just to show you for. So that data, if you go down here, I have. This is actually the calculator you use to test normality. It's A26. You just put the numbers in there, and it'll tell you if that is normal or not. So if you need to actually test your data at some point to tell you to figure out it's normal, this is the calculator for that. I won't have you actually test it on the test stuff. All right. In a previous poll, 40% of adults under the age of 18 or children under the age of 18 reported their family ate dinner together 7 nights a week. Suppose that in a more recent poll of 1,137 adults with children under the 18 were selected at random, 430 of those reported their family ate dinner together 7 nights a week. Is there sufficient evidence that the proportion of families with children under the age of 18 who eat dinner together 7 nights a week has decreased? Use a significance level of 0.1 level. So this is a hypothesis test. Which one is it? Proportion or mean? Huh? Proportion. So we're going to use a proportion test. So what is my null hypothesis? Yep. And my alternate hypothesis? Yes, because it says decreased. And what is my proportion, my sample proportion now? It's 430 out of 1,370. Can somebody do that calculation real quick? 430 out of 1137. 0.38. Thank you. Okay. I think actually. Oh, never mind. I forgot. I actually put it in the thing, so you don't have to worry about that. You can actually type it in. My hypothesis was 0.40, and my significance level they want is 0.1. Nope, 0.1. It's not life or death if your kid doesn't eat with you. So it's a left tail test. Make sure these match what you have. The requirements are met. It is normalized. There's my sample proportion. My z-score is negative 1.5013. My p-value is 0.0666, which is less than the 0.1. It is also within the critical region there, so we are rejecting the null hypothesis. So is there sufficient evidence that the proportion has decreased? Yes. I will say, and I haven't totally finished grading everybody's tests, but the answer to this question, when the way it's worded, it doesn't say, did I reject or fail to reject my null hypothesis? It asks you, is there sufficient evidence? So say that. So say, yes, there's sufficient evidence that the population or the percent has decreased. That's fine. Okay? Don't say fail to reject. I will take off points for that. Okay? I'll have all your tests graded tomorrow. They'll be in Blackboard. All right, last one. Credit scores used by credit agencies to assess credit worthiness of individuals ranges from 300 to 850, with the credit score over 700 to be considered a quality credit risk. According to the survey, the mean credit score is 702.9. Credit analysts wondered whether high-income individuals, incomes in excess of $100,000 per year, had higher credit scores. He obtained a random sample of 30 high-income individuals and found that the sample mean credit score to be 716.9 with a standard deviation of 83.7. Conduct the test to determine if higher income individuals have higher credit scores at the 0.05 level of significance. So what kind of test is this? This is a mean hypothesis test. So what's my null hypothesis? Yeah, 702.9. Alternate hypothesis? Nope, remember these two numbers have to be the same. It's greater than, that's the change. Okay. Now, my sample mean is 716.9, and my sample standard deviation is 83.7, and my A is 0.05. So I think this one's 33. Yeah. So this is A33. 716.9. Yeah. 83.7. How many do they take? 30. Okay. So put that in. We want greater than. So make sure that those match. My test statistic is 0.9161, which means it falls into that area there. My p-value is 0.1836, so I'm failing to reject. So there's insignificant evidence to say that high-income individuals have a higher mean credit score. That's your final. I'm probably going to drop it down to 10 questions because I'll probably combine some of the stuff. But don't be shocked if it's 12. It won't be 15. I just don't know if I'm going to be able to cut out 5 questions or if I'm going to be able to cut out 3. I know I'm going to be able to cut out 3. I have to see if I can combine some other stuff to make it 10. So here is how the final is going to work. If you want to come in earlier in the week, I'm here till 2 o'clock every day. You're more than welcome to come before Thursday if you can come during the day and take your test. So if you have another final during the day and you want to come get it done with, you're more than welcome to. I'll be in E206. Okay? On Thursday, I will be in E206 all day until 9:30 that night. Next Thursday. So I'm not going to come. It's going to be easier for me to do it that way than constantly swapping back rooms. So I'm literally just going to be in E206. Come in anytime you want on Thursday and take your test. Okay?
What's the earliest you can go Thursday?
7:30 in the morning. Like I have to be here at 7:10. So if you want to come in that early, get your test done, be my guest. Okay? So yeah, I'll be here at 7:30 in the morning, and my final test is supposed to end at 9:30. So I will be gone when the last person leaves. Okay? So I really don't want to be here till 9:30, so I'm kind of hoping they come earlier. But yeah, you can come anytime you want. All right? If you want to come earlier during the week to finish up your test earlier, that's totally fine. I will have the test ready for Monday. All right? Don't forget your projects are due tonight. So if you have not sent me your email with your project or have not given it to me, it's due by midnight. Okay? Any other questions? Remember, E206 for the final exam. I'll put a sign on the door, don't worry. All right. Have a wonderful night. I will see you next Thursday. Oh, and don't forget to fill out the survey on Blackboard. Even if you totally hated me, it's fine.
Thanks, Tony. You're way better than the English teacher.
You're welcome.
She got the thumbs down.
Oh, God.
Thank you.
You're welcome. Hey, Julia, where did you compete last weekend? Where were you competing this weekend?
Florida.
What was the name of the tournament?
Summit.
I was looking and I found that one on YouTube, and I'm like, I wonder if this is the one she went to. Yeah.
Because you said you're going to take marks off if you use this statement, like reject or not reject. I didn't know, so I put it on the test, but I think I put it on the test. So should I probably take it out up here then, I guess, from the project, or it doesn't matter?
Wait, how did you word it? It really depends on how you word it.
Oh, okay.
Yeah, that way is fine. What you can't say is that the other direction. You can't say I reject my alternate hypothesis, or I can't say that you know for a fact that isn't true. The other, what you thought was true, is true.
Okay.
That's fine.
Okay. All right. Thank you.
You're welcome.